Exam link 1. Direction of motion of particle on a longitudinal wave. You have to find the direction of motion of g, and therefore direction of its velocity at time t1 and t2. Since the wave passes from left to right, the motion of g follows that of f. Also, you should know the amplitude of motion since particles with maximum displacement are momentarily at rest. At time t1, g has zero displacement. It is at its own equilibrium position, and it will move to the right because f is already on the right of its equilibrium position. At t2, g has a displacement of 5 units, which is the maximum displacement, and hence g is momentarily at rest at t2. On the other hand, you may also sketch the displacement distance graph around g and deduce the motion of g, as illustrated by the solution below. B. Displacement time graph. Similar to transverse waves, we may also use displacement time graph of a particle to represent longitudinal waves. Such a graph shows how the displacement of vibration of a particle changes with time. In the following snapshot, let's focus on particle A only. Its displacement changes from 4 to 3 to 0 to -3 to -4 and so on. The displacement changes like a cosine curve when you turn the book by 90 degrees. Similar to the displacement time graph of a transverse wave, you can find the period and amplitude of the wave motion as shown on the next page. On the other hand, a displacement distance graph may let you find the wavelength and amplitude of a wave. Together, you can find the wave speed by using the formula v equals f lambda equals lambda over period. By the way, if you want to convert the graph from one type to another piece of information must be supplied. Please refer to the illustrations on page 26 and 27. Do check point 3 below.